All right, we are back with part 2 of the lesson 4 notes. And we're on page 17 in the packet. Example 3 is a lot like an example that we did in lesson 3, where we're given two separate angles and we have to find the values of their sum. So the sine of a plus b and the tangent of a plus b. And we have this bonus problem here, finding the quadrant of a plus b. So let's take this one thing at a time. To find the sine of a plus b, this comes from our identity. We have sine a cosine b plus cosine a sine b. So let's look at what we have. Suppose A and B are angles in standard position, where sine A is 4/5 and A is between pi over 2 and pi. So if A is between pi over 2 and pi, that tells me that I'm in quadrant 2. That's what that's telling me right there, if I'm between pi over 2 and pi. Cosine B is negative 5/13, where B is between pi and 3 pi over 2. If we're between pi and 3 pi over 2, that means we're in quadrant 3. So just like in the last lesson, we are going to draw a triangle for both angle A and angle B to find our missing information in order to figure all of this out. Okay, so I'm going to do my triangles down here where they're a little bit out of the way. So here's angle A, and we're told that angle A is in quadrant 2, remember? And that its sine is 4/5. Now we like this because this is a 3, 4, 5 triangle, which means that cosine A is negative 3/5. All right, now let's also do angle B. And remember, angle B is in quadrant 3, so make sure you're drawing your triangle accordingly. And we're told that cosine B is negative 5/13, adjacent over hypotenuse. Again, this is a Pythagorean triple. This right here is going to be negative 12. So sine B is negative 12/13. And now we should have everything we need to figure this out. So sine A was given to us is 4/5. Cosine B was also given to us, negative 5/13, plus cosine A we had to figure out. That's our negative 3/5 there, times sine B we had to figure out here, negative 12/13. And then we go through and simplify. That gives me negative 20/65 plus negative 36/65. If I put those together, that gives me negative 56/65. Actually, sorry. Negative times a negative is a positive, which means that my answer is 16/65. I'm a little rusty after a couple weeks off here. All right, let's try part B, tangent of A plus B. Well, in order to do tangent of A plus B, I need tangent A plus tangent B over 1 minus tangent A times tangent B. Now, I don't know tangent of A or B. However, I can use the triangle here to figure it out very quickly. So, tangent is opposite over adjacent. So, tangent A is going to be opposite over adjacent. So -4/3. Tangent B, again, opposite over adjacent. A negative over a negative gives me positive 12/5. Okay, now I have what I need. Plug them in. Tangent A is -4/3 plus tangent B is 12/5 over 1 minus tangent A times tangent B. So all of that is plugged in. Now to simplify this, I'm going to have to get a common denominator on the top. Common denominator for 3 and 5 is going to be 15. So multiply that by 5 over 5. That's going to give me -20 over 15. 3 over 3, that's going to give me 36 over 15. So now I can add those together. On the top, that gives me 16 over 15 over 1 plus, because a negative minus a negative, 48 over 15. Now to add these together, I'm going to think of 1 as 15 over 15, which gives me, on the top, I still have 16 over 15. 15 plus 48 is what, 63? When you divide fractions, that's the same thing as multiplying by the reciprocal. So I have 16/15 times 15 over 63. Those 15s are going to cancel out, and we're simply left with 16 over 63. Okay. The quadrant of A plus B. How are we going to know the quadrant of A plus B? Well, what do we know about A plus B? We know its sine, and we know its tangent. We know its sine is 16 over 65, and we know its tangent is 16 over 63, which are both positive. So if both the sine and the tangent are positive, the only possibility is that it's in quadrant 1. So since both the sine of A plus B and the tangent are positive, A plus B must be in quadrant 1. All right, one last example here. Verify that the equation is an identity. And there's one typo here. This should say pi over 3 plus x. So verify. That means I'm going to change only the one side to get it to match the right side. So this is a sum here. We have a sine sum and a cosine sum. So let's write this out. This is going to be sine pi over 6 times cosine x plus cosine pi over 6 sine x. Then the cosine identity, remember, goes cosine, cosine, sine, sine, but it's going to be a minus. So we're going to have cosine pi over 3 cosine x minus sine pi over 3 sine x. All right, now let's fill in what we know here. Sine of pi over 6 is 1/2. Cosine of pi over 6 is square root of 3 over 2. Cosine of pi over 3 is 1/2. Sine of pi over 3 is square root of 3 over 2. All right, let's try to simplify this. Well, 1/2 cosine plus 1/2 cosine is cosine. And square root of 3 over 2 sine x minus square root of 3 over 2 sine x, those are going to cancel out. And hey-o, both sides do in fact equal cosine x. So we have verified that those two sides equal each other. Pretty neat. All right, that is it. We will see you soon.